Welcome back to All This Math. This is Professor Parker, and today we're going to talk about division, but division more as a concept, right? We're going to do the problems, but we're going to talk about it more as a concept because the concept is key, all right? Also, make sure you are subscribed to the All This Math YouTube channel. Please like, subscribe, and share, this video and whatnot. Um, I got four examples up here on the board, right? The first one says 10 divided by 5. The second one says 16 divided by 6. The third one says 3/8 or 3 divided by 8 because remember, a fraction is just a representation of a division problem. That's another way to represent a division problem by writing it as a fraction. All right. Numerator on top, denominator on the bottom, fraction bar in the middle. And then 28 divided by 9 or 28 ninths. All right. Let's talk about the first one, 10 divided by 5. So 10 would be our dividend, right? And 5 would be our divisor. So whenever we're doing division, what we're basically trying to figure out is this. How many of the second number can fit into the first number? That's basically what we're doing. We're trying to figure out how many fives or groups of 5 can fit into 10. So how many of the divisor can fit into the dividend? How many of the divisor can fit into the dividend? All right. Or how many of the denominator can fit into the numerator? So if we say, we count by fives, we go 5, 10, right? So two groups of 5 can fit into 10. That's why the quotient, right? The quotient is the answer when we do division. That's why the quotient is 2, because two groups of 5 can fit into 10. All right. That's why. That's as conceptually. That's what's really happening. Now, what about when we do 16 divided by 6? We're asking the question, how many sixes can fit into 16? How many sixes can fit into 16? So I know if I count by sixes and I know my multiplication facts, I know if I do 6 times 3, that's going to give me 18. That's more than 16, right? But if I do 6 times 2, that's going to bring me to 12. That's less than 16. So I know two whole groups of sixes can fit into 16, but it's some left over though, because 6 times 2 does not equal 16. 6 times 2 equals 12, and 12 is less than 16. So what we're going to end up with is what we call a mixed number. Some people call it a mixed numeral, but I call it a mixed number, right? Why is it mixed? Because it's got a whole number part and it's got a fraction part. It's a mixture of two types of numbers, a whole number and a fraction, right? Well, you could be an integer because it could be negative. So we really technically, I should say, it's a mixture between an integer and a fraction, an integer and a fraction. All right. So I'm gonna write my 2. Now again, where did 2 come from? Two full whole groups of 6 can fit into 16, right? Because 6 times 2 gives me 12, but 12 is less than 16. So that's why I'm gonna have a fraction part, because two whole groups of 6 can fit in and a fraction of another group of 6. So two whole sixes and a fraction of another group of sixes. Now, what is that fraction though? This is how you figure out what that fraction is. You take the difference between the 12, because 6 times 2 is 12, and two whole groups of sixes is 12. The difference between that 12 and the 16 is 4. So 4 is going to be your numerator in your fraction. 4 is your numerator in your fraction. And then what's your denominator? Your denominator was the original divisor, 6. So basically what this is saying is this information is telling us that how many sixes can fit into 16? Two whole groups of sixes and 4/6 of another group of 6. Now, what does that look like? If you took this rectangle like this, right? And let's say I break it down into 6 equal parts, right? So now I got that and that's 3 over there. And I got 3 over here. So that's a total of 6. 1, 2, 3, 4, 5, 6. Now, how many of this, like this is a whole group of sixes, right? A whole group of 6. And one piece or 1/6, another 1/6, another 1/6, another 1/6. And that's it. 4 of them. 1, 2, 3, 4. This is how many, right? This piece right here, out of the whole group of 6, 4 of them can also fit into 16. So two whole sixes, right? And 4 parts of another group of sixes, or 4/6. Now, we also should talk about reducing fractions since we're on the topic, or since we got a mixed number with a fraction that can be reduced. 4/6 can be reduced and become, well, the 2 is going to stay the same. 4/6 can become 2/3. Now, why does it become 2/3? Because the common factor between 4 and 6 is the number 2. So you divide each of these numbers, the numerator and denominator, by 2, and 4 divided by 2 equals 2. 6 divided by 2 equals 3. Also, if you think about it like this, look at this picture I drew, right? It's got 1, 2, 3, 4, 5, 6 pieces, right? Now, every 2 pieces, if I break this down differently, this is 1/3, this is 1/3, and this is 1/3. Every 2 pieces is 1/3 because I just broke this whole thing up into 3 equal parts. 3 equal parts. 1, 2, 3. 1, 2, 3. That's 3 equal parts. Now, if this is all shaded in, that's one whole part, and this is all shaded in, that's 2 whole parts. So that's 2 parts out of 3 parts altogether. That's 2 parts out of 3 parts altogether. 1, 2, 3. Right? That's where the 2/3 comes from. That's where the 2/3 comes from. But if I don't reduce it, I got 6 parts altogether. 1, 2, 3, 4, 5, 6. And I got 1, 2, 3, 4 parts shaded in. That's why the 4/6 makes sense. The 4/6 makes sense. Also, the 2/3 makes sense. But when we deal with fractions, we should always reduce them, though. Always reduce them so our numbers in a fraction are the smallest that they could possibly be. 2 is less than 4, 3 is less than 6. So that's actually a better answer. That's what we call a simplified answer. All right, we always want to simplify our fractions whenever possible. All right, now let's look at these last two. 3/8. Now, another way I like to describe this to students is this. And this kind of helps us to get an idea of what our answer will be, whether we'll have a mixed number answer or we'll have a fractional answer, a proper fraction answer. Proper fraction, of course, has a numerator smaller than the denominator. That's more proper. That's more appropriate, right? Mathematically speaking. The denominator is like the size of somebody's foot. The numerator is the size of the shoe, right? So let's say your foot is a size 8. Your foot is a size 8. And then you try to put your foot into a size 3 shoe. What's going to happen? It's not going to fit. Your whole foot is not going to fit. And your whole size 8 foot is not about to fit into a size 3 shoe. Only a fraction of your foot, only a fraction of your size 8 foot will be able to fit into a size 3 shoe. So that lets you know that this answer is going to be a fraction, right? So 8 into 3, and actually this is already reduced, right? So we're trying to figure out how many groups of 8 can fit into 3. How many groups of 8 can fit into 3? 3/8. 3/8. How many groups of 8 can fit into 3? Because a whole group of 8 can't fit into 3, right? A whole group of 8 can't fit into 3. But if you broke that 8 down into 8 equal parts, broke this 8 down into 8 equal parts, 3 of those parts will be able to fit. So that's what this represents. So really, we can't even, there's no real work to be done here, right? This is just a representation. So we would just say 3/8 is equal to 3/8. We could convert it to a decimal if we wanted to, right? If we did that, 1/8 is the same thing as 0.125, and 0.125 times 3 is 0.375. So we could do that, but just understand the concept though. Like I said, I'm really focused on concepts in this video, right? How much of a size 8 foot can fit into a size 3 shoe? 3/8 of it. So that means 5/8, because the whole thing would be 8/8. 5/8 of the foot would not fit into that shoe. 3/8 could fit into the shoe, but 5/8 could not. All right. So another way to understand, think about the concept. The denominator or the divisor, those are the same. Numerator or the dividend is on top, right? You could think of the denominator or the divisor as the foot size. You could think of the numerator or the dividend as the shoe size. Now let's apply this to 28/9. So if you have a size 9 foot and you want to fit it into I don't know, one of these like 7 foot, almost 8 foot basketball players, they might wear a size 28 shoe, right? They might, I don't know. Might wear a size 28 shoe. So if you got a size 9 foot, how many of your foot or how much of your foot can fit into a size 28 shoe? Well, since 9 is less than 28, your whole foot can fit in there. And again, at least 3 times. 3 of your feet could fit into a size 28 shoe. Why? Because 9 times 3 is 27. And that's also why it's very important to understand and have memorized multiplication facts. Because if you have multiplication facts memorized, when you start thinking about division and concepts and fractions, it comes much more easily because you don't got to take the time to worry about oh, like what's 9 times 3 or what's 9 times 2. You just know it. So 3 of these size 9 shoes, or size 9 feet rather, can fit into a size 28 shoe. Now, but there's some left over because 9 times 3 is 27. It's not 28. So similar to this problem up here, right? So we're going to have a mixed number. So we got 3, and then we have one part left over. All right. So if we took this 9, this size 9 foot, and broke it down into 9 equal parts, the difference between 28 and 27 is 1. So there will be one of those ninths left over. There will be 1/9 left over, just like there was 4/6 left over up here, or 2/3 after we simplified and reduced. But there will be 1/9 left over. So 3 nines can fit into 28. That takes us to 27. But remember, we're trying to get to 28. We're trying to get to 28. So we take the 9, think of the 9 as being broken down into 9 equal parts. And then one of those parts can also fit into the size 28 shoe. So imagine size 28 shoe, size 9 foot. One of your feet can fit, another one of your feet can fit, that's 18. Another one of your feet can fit, that's 27. And then you take your foot, imagine, right? Imagine, because we're not going to actually cut your foot, but imagine that we divided your foot up into 9 equal parts. One of those parts will be 1/9. One of those parts will be 1/9. So we got 1, 2, 3, and 1/9. That's why the answer is 3 and 1/9. And then if we wanted to check our work, we would just multiply this out, basically doing what I just did, a variation of it. We do 3 times 9, which is 27. 27 plus 1 is 28. And then we keep the same denominator for 28 ninths. All right. So this is just a little something I wanted to throw together to talk about division as a concept. Division as a concept. Like what is actually happening when we do division. Because a lot of people learn division, but they may not fully understand the concept behind what's actually taking place when they're actually doing division, even if they're getting the right answer. Because it's very possible in math to get correct answers, but still not fully understand what you're doing. So I want people to understand what they're doing and what's actually going on in terms of the relationships between the numbers. Like 10 divided by 5 is 2. A lot of people memorize that, and that's cool. But what does that really mean? That means that 2 groups of 5 can fit into 10. 16 divided by 6 is 2 and 2/3. What does that mean? That means that 2 groups of 6s can fit into 16, and 2/3 of another group of 6s can also fit into 16. All right. And then 3/8 is just 3/8 because that can't be reduced. This means that if you want to know how many 8s can fit into 3, or how many groups of size 8 can fit into a group of 3, 3/8 of that group of 8s, of that group of 8 can fit into 3. And 28 ninths, how many groups of 9 can fit into 28? 3 whole groups of 9, and then 1/9 of another group of 9. So 3 whole groups of 9 and 1/9 of another group of 9 can fit into 28. All right. So division as a concept. I hope that helps. We also have other videos on the division playlist that you might want to check out. All right. Make sure you are subscribed. And oh, also before I forget, shout out to these brothers, these ancestors that are on this hoodie. We got Gabriel Prosser, who led or planned out slave rebellion back in, I want to say, 1804, Richmond, Virginia, right? It was foiled. It didn't really come to pass because of a torrential rainstorm, and also a couple of people snitched. A couple of enslaved Africans that wanted to be enslaved, they snitched on them. Gabriel Prosser, Denmark Vesey, of course, 1822, in Charleston, South Carolina. I think it was Charleston. Yeah, Charleston, South Carolina. Nat Turner, of course, 1831, Southampton County, Virginia. Charles, I believe this refers to Charles de Lande, who led the German Coast Rebellion down in New Orleans in 1811. And this brother right here, I do not know, or a sister, it might be a sister, I'm not sure. I do not know who this is. I need to do some more research to find out who this person is. This person named Johnson. So I need to know them since I'm wearing them on my hoodie. But yeah, definitely shout out to those ancestors that decided, like, we're not gonna be enslaved. We out. You know what I'm saying? Because you often don't hear that in school history classes and in school textbooks, because there's a narrative that wants to be put forth about black people, and that we had to somehow like wait for some white man, Abraham Lincoln, to free us. But that's not the reality of the situation. Once we do more reading, we find out what the reality is. So anyway, make sure you're up on that and practice division. And when you're doing division, Think about the concept of division and what's actually happening with the numbers. Think about the relationships between the numbers and what's actually happening with the numbers if you need to. And if it's helpful, draw a little diagram, a math drawing. We call these math drawings, right? Draw a little diagram if you need to. You know what I'm saying? And that's about it. I'll see y'all in the next video.